All right, let's talk about Kubernetes. If you're running it across multiple clouds, you already know how powerful it is. But you've probably also felt the pain, right? Especially when it comes to storage. Well, today, we're going to untangle that knot. We're going to architect a unified strategy that finally brings some simplicity and order to all that chaos. So, does this sound familiar to you? You're there, orchestrating these incredible applications with Kubernetes, but when it comes to persistent storage, you're stuck. You're juggling three different sets of rules, three different provisioners, three totally different ways of thinking about things. It's a recipe for complexity, and honestly, it can get pretty overwhelming. So for this explainer, I want you to put on a different hat, okay? You are the senior multi-cloud architect, and you've been given a mission, a really critical one. Cut through all this complexity, standardize everything, and bring some serious order to that storage chaos. And here's our game plan for that mission. We'll start by really defining this maze we're in. Then we'll figure out a path to consistency. I'll introduce you to our key tool, the Unified Storage class. Then we'll lay out the actual architect's blueprint. And finally, we get to celebrate the payoff. Okay, first things first, let's really map out the problem. We're calling this the multi-cloud storage maze, and for a very good reason. It is a tangled, complicated web of inconsistency that just slows your teams down and creates a ton of operational friction. This table right here, it paints the picture of chaos perfectly. Look at it. On AWS EKS, you're using the EBS CSI driver. Hop over to Azure's AKS, and nope, it's a completely different disk CSI. And Google GKE, you guessed it, another one entirely. But you know the really scary part, the thing that's a huge operational risk, is the backup policies. They're all over the place, manual, ad hoc, project level. I mean, this means there's no single consistent way to know your data is safe or that you can actually recover it predictably. That's a big problem. So if that's the mess we're in, what does good even look like? This brings us to our second part, figuring out what we're aiming for, defining that end goal of real storage consistency. This right here, this is our North Star. The goal is just to make storage provisioning feel exactly the same no matter which cloud a developer happens to be deploying to. It has to be consistent, it has to be predictable, and maybe most importantly, it's got to be simple. So why do we care so much? Why does this really matter? Well, because the benefits, they go right to the bottom line. You get faster application deployments because your developers aren't constantly switching context. You get a much simpler developer experience, which just skyrockets productivity. Your platform team, they see a huge reduction in operational overhead. You get a backup and recovery strategy you can actually rely on. And this is the big one, you get true infrastructure portability. You can actually move workloads without having to re-architect your storage from scratch. Now, to pull this off, we need the right tool for the job. And in this particular architecture, our secret weapon, or key to unlocking all of this consistency, is something called the Unified Storage class. So what in the world is a Unified Storage class? Think of it like a universal adapter for storage. It's this abstraction layer that you define inside Kubernetes. So instead of your developers having to know all the cloud-specific jargon like GP3 or PD-SSD, they just ask for a storage profile, something simple like standard SSD. The Unified Storage class then does all the translation in the background, automatically setting up the correct storage and hiding all those nitty-gritty complex details. Okay, now for the fun part. How do we, as the architect, actually build this thing? Let's get into the blueprint and turn this really cool concept into a working reality. This table right here is the heart of the entire strategy. On the left, you've got our simple unified names, standard SSD and premium SSD. And on the right, you see how it all maps to each cloud's native technology. So a developer asks for standard SSD, and boom, Kubernetes automatically provisions GP3 on AWS or standard SSD LRS on Azure. All that underlying complexity is just handled for them. It's really elegant. And the path to get there is actually pretty straightforward. First, you define your performance tiers. What do your apps actually need? Second, you take those chaotic backup policies and you standardize them into one single reliable approach. Third, you get in there and you write the Kubernetes YAML manifests for your new unified classes. And finally, you just deploy them across all your clusters, EKS, AKS, and GKE. And after that work is done, we get to the best part, the payoff. It's time to celebrate the victory and really look at the tangible results of bringing order back from the chaos. And the results are immediate, and they are so measurable. Deployment time for stateful apps just drops significantly. Management overhead plummets because now your team is maintaining one storage strategy, not three. And onboarding new developers, it's way faster because they only have to learn one simple abstraction. These aren't just lines on a chart. They represent real, tangible gains in speed and efficiency for your entire organization. So, the most important takeaway here is this. You, the architect, have successfully navigated the maze. You've taken a system that was complex, fragmented, and just begging for errors, and you've replaced it with a single, elegant abstraction that empowers your developers and totally simplifies your operations. So, you've done it. You've tamed the storage beast. And that is a massive win that opens up so many new possibilities. So the question I'll leave you with is this. Now that your storage is unified, what's the next piece of multi-cloud complexity you're going to conquer? Thanks for watching.